Hello everyone, welcome to my channel EE Concepts in 5 minutes. Today I will discuss about maximum power transfer theorem. So coming to the statement of maximum power transfer theorem, it states that maximum power is transferred from source to load when source resistance is equal to the load resistance. Okay, now coming to the procedure of this maximum power transfer theorem. So I want to find the load resistance here. So first of all, open circuit this is the procedure, load resistance. Open circuit the load resistance and find V Thevenins across the load resistance. Coming to the second point, short circuit the voltage source and find R Thevenins across the load resistance. Short circuit the voltage source and find R Thevenins. Suppose in place of voltage source there is a current source, we open circuit the current source. Okay, now replace the circuit by Thevenin's equivalent circuit. Now find the power through the load resistance by using the formula power P equal to V Thevenin's square by 4 into R Thevenin's. This is the maximum power transferred from source to the load. P equal to V Thevenin's square by 4 into R Thevenin's. V Thevenin's is obtained from the first step and R Thevenin's is obtained from the second step. Okay, now let us solve this problem based on this procedure. Okay, so first of all, I will open circuit the load resistance. Open circuit the load resistor. This is 20 ohms, 10 ohms and 5 ohms, 20 volts. So I will find V Thevenins here. To find V Thevenins, okay, I will use the direct Ohm's law. So now since this is open circuited, these two are in series. So the current passing through the circuit is V by R, that is 20 by R is R1 plus R2, 15. Okay, so this is equals to 1.33 amperes. So the voltage across the 10 ohm resistor, V Thevenin's is the voltage across the 10 ohm resistor, that is 1.33 into 10 to 13.3 volts. 13.3 volts. Okay. So now let us find R Thevenin's here. R Thevenin's short circuit the voltage source. This is my R Thevenin's 20 ohms, 10 ohms and 5 ohms. Now 5 ohm and 10 ohm are in parallel and this combination is in series with 20 ohms. So R Thevenin is equal to R1 R2, that is 10 into 5 by 10 plus 5. 10 into 5 50 by 10 plus 5 15 plus 20. Okay, R1 into R2 by R1, that is 50 by 15 plus 20. This is equals to 21.33 ohms. So I will replace this circuit by Thevenin's equivalent circuit, that is 13.33 volts in series with 21.33 ohms in series with the load resistor, that is okay. Now coming to the load resistor here, from the statement of maximum power transfer theorem, okay, maximum power is transferred from the source to the load when source resistance is equal to the load resistance. So we have to replace this source resistance by the load resistance. So both are one and the same. Please remember that R Thevenin will be equal to RL here. RL equal to R Thevenin. Okay. So this now power P equal to V Thevenin square by 4 into 21.33. So this is the maximum power transferred from the source to the load. Okay, thank you for watching my channel and please subscribe for more videos. Thank you.